The Gulf of Mexico is an ocean basin and a marginal sea of the Atlantic Ocean. Largely surrounded by the North American continent, it is bounded on the northeast, north and northwest by the Gulf Coast of the United States, on the southwest and south by the Mexican states of Tamaulipas, Veracruz, Tabasco, Campeche, Yucatan, and Quintana Roo, and on the southeast by Cuba, the U.S. states of Texas, Louisiana, Mississippi, Alabama, and Florida, which border the Gulf on the north, are often referred to as the third coast of the United States. The Gulf of Mexico took shape approximately 300 million years ago as a result of plate tectonics. The Gulf of Mexico basin is roughly oval in shape and is approximately 810 nautical miles. The Gulf of Mexico is one of the most important offshore petroleum production regions in the world, making up 1/6 of the United States' total production. The International Hydrographic Organization defines the southeast limit of the Gulf of Mexico as a line joining Cape Catoche lie thence through the shoals and Florida Keys to the mainland at the eastern end of Florida Bay and all the narrow waters between the dry Tortugas and the mainland, being considered to be within the Gulf. The consensus among geologists who have studied the geology of the Gulf of Mexico is that before the late Triassic, the Gulf of Mexico did not exist before the late Triassic. The area now occupied by the Gulf of Mexico consisted of dry land, which included continental crust that now underlies Yucatan, within the middle of the large supercontinent of Pangaea. This land lay south of a continuous mountain range that extended from north-central Mexico, through the Marathon Uplift in West Texas and the Ouachita Mountains of Oklahoma, and to Alabama where it linked directly to the Appalachian Mountains. It was created by the collision of continental plates that formed Pangaea, as interpreted by Roy Van Arsdale and Randall T. Cox. This mountain range was breached in late Cretaceous times by the formation of the Mississippi embayment. Geologists and other earth scientists agree in general that the present Gulf of Mexico basin originated in late Triassic time as the result of rifting within Pangaea. The rifting was associated with zones of weakness within Pangaea, including sutures where the Laurentia, South American, and African plates collided to create it. First, there was a late Triassic early Jurassic phase of rifting during which rift valleys formed and filled with continental red beds. Second, as rifting progressed through early and middle Jurassic times, the continental crust was stretched and thinned. This thinning created a broad zone of transitional crust, which displays modest and uneven thinning with block faulting, and a broad zone of uniformly thin transitional crust, which is half the typical 40 km thickness of normal continental crust. It was at this time that rifting first created a connection to the Pacific Ocean across central Mexico and later eastward to the Atlantic Ocean. This flooded the opening basin to create the Gulf of Mexico as an enclosed marginal sea. While the Gulf of Mexico was a restricted basin, the subsiding transitional crust was blanketed by the widespread deposition of Luan salt and associated anhydrite evaporites. During the late Jurassic, continued rifting widened the Gulf of Mexico and progressed to the point that seafloor spreading and formation of oceanic crust occurred. At this point, sufficient circulation with the Atlantic Ocean was established that the deposition of Luan salt ceased. Seafloor spreading stopped at the end of Jurassic time, about 145 to 150 million years ago. During the late Jurassic through early Cretaceous, the basin occupied by the Gulf of Mexico experienced a period of cooling and subsidence of the crust underlying it. The subsidence was the result of a combination of crustal stretching, cooling, and loading. Initially, the combination of crustal stretching and cooling caused about 5 to 7 kilometers of tectonic subsidence of the central thin transitional and oceanic crust because subsidence occurred faster than sediment could fill it. The Gulf of Mexico expanded and deepened. Later, loading of the crust within the Gulf of Mexico and adjacent coastal plain by the accumulation of kilometers of sediments during the rest of the Mesozoic and all of the Cenozoic further depressed the underlying crust to its current position about 10 to 20 kilometers below sea level. Particularly during the Cenozoic, thick clastic wedges built out the continental shelf along the northwestern and northern margins of the Gulf of Mexico. To the east, the stable Florida platform was not covered by the sea until the latest Jurassic or the beginning of Cretaceous time. The Yucatan platform was emergent until the mid-Cretaceous. After both platforms were submerged, the formation of carbonates and evaporites has characterized the geologic history of these two stable areas. Most of the Basin